In this video, we'll have a review on Newton's laws and dynamics. Take note that from the previous modules is that we've discussed about kinematics, in which it describes the motion of an object by answering the following questions without even knowing the causes of it. Well, here today, we'll be dealing with dynamics, in which it studies the causes of the changes in the motion of an object. So basically, it's because of the presence of forces. Well, force is simply an interaction of one object to another or to its environment. It is a vector quantity, meaning to say it has magnitude and direction, and its SI unit is in newtons. Take note that 1 newton is simply equivalent to 1 kilogram meter per second squared. Okay, meters per second squared. So take note that if there are two or more forces acting on an object, the total force is simply the vector sum of that forces, which is simply also called as the net force. And also, the net force can be expressed in terms of its components, such as x, y, and z. Take note that if it's a vector, kailangan mo ma-add ang vectors whenever nasa along x, naka-component siya along x, y, and z. These forces can be classified into two. One is what we call as contact forces, in which it results from physical contact between two objects. Examples of this are applied force, friction, tension, and many other. The other one is what we call as field forces. These are long-range forces applied to an object that is not in direct contact with each other, or also known as action at a distance force. Examples are electric force, magnetic force, and gravitational force. There are kinds of forces too. One is what we call as gravitational force. This is a pull of gravity on any object. The other one is what we call as normal force, a supporting force on any object which is perpendicular to the surface of contact. Take note, gikan sa word itself normal, meaning to say perpendicular. Ay haranay normal force kung na surface of contact. Next, and I forgot also when we say gravitational force, it is sometimes called as weight. Okay? And its equation is simply equal to mass times acceleration due to gravity, g. The other one is what we call as friction. This is sometimes called as resistive force. It always resists the motion of an object. So for this case, example, the motion is towards right, so ang friction is the opposite towards left, and it is always parallel to the contact surface. Next is what we call as tension. So this is simply force being transmitted to cables, wires, or strings. Okay, next is what we call as centripetal force. This force is acting on any object moving in a circle or a curve. And also we have buoyant force. This force is exerted by a fluid that opposes the weight of an immersed object. So take note that I haven't mentioned all the forces, but these are the common nga mga forces nga ma-mention ani nga course. The Newton's laws of motion is formulated by Sir Isaac Newton. It is a fundamental law used to understand the most familiar kind of motion. And this law is deduced gikan sa multiple experiments nga gi-perform, and one of them was Galileo Galilei. And take note that these laws of motion is applicable only to classical mechanics. When we say classical mechanics, isa ni siya sa mga branches of physics dealing with objects nga visible to the human eye, pero ang speed sa object dili molapas sa speed of light. So our first law of motion, or the law of inertia, would state that an object at rest will remain at rest, an object in motion will remain in motion with constant velocity unless a net external force acts on it. Naay duha ka situation ani nga law of inertia. One is simply ang usa ka object nga at rest will remain at rest forever as long as walay net external force gaak sa iyaha. So, a book nga nasa usa ka table is forever at rest unless otherwise tagaan nimo siya net external force mao nang mulihok siya. Or pwede po na ikaduha nga situation is ang object moving with constant velocity. So, ang tendency, it moves in the same direction, the same speed. So, forever na siya mudagan given that walay friction, walay barrier, and so on. Pero kung na net external force, for example, in the presence of a barrier, in the presence of friction, so kana siya, disobey na siya sa law of inertia. If the object obeys the Newton's first law or the law of inertia, that object is said to be in equilibrium. So pasabot iyahang net external force is equal to 0. And the vector sum of all the forces is also equal to 0. So again, take note, that would only mean kung in equilibrium di ay, meaning to say balance imuhang mga forces. So regardless, one, kung ang usa ka object at rest, yeah, acceleration is also equal to 0. Pwede pod in motion with a constant velocity, both in magnitude and direction, still ang acceleration is equal to 0. So, to sum up for that one, ang components sa usa ka vectors along x, along y, and along z is also equal to 0. For example, a book resting on a table, so ang tendency is that ang table may exert og upward force onto the book in the form of a normal force. Okay. And at the same time, ang book may exert og force onto the table in the form of weight. Okay, so basically, if you're going to add the force acting along y, so meaning to say, given that this is positive y ang direction diriyan, then negative y ang direction downward, so ang tendency is that you'll have here normal force which is upward, so meaning to say it's positive, and your weight is simply downward, so negative. So there are two forces lang agi-add, so that means to say that's equal to 0. So if you're going to add W or weight both sides of the equation, so your normal force is simply equal to its weight. Okay, so we need to say balance ang duha ka force. The other one is what we call as the law of acceleration. So it would simply mean that kung na daw net external force gaak sa usa ka object nga nay mass m, kana nga object mo accelerate in the direction of the net external force. Or this gives rise to the famous equation F is equal to ma. So basically, here's an object A and then I net external force gaak sa iya, so ni accelerate at this direction. Even the car itself. So take note that again, kani ang famous nga equation nga F is equal to ma. So the greater the mass, the greater the force to cause a given acceleration, given nga mass is constant. So here, the dynamics of the objects, take note, this will give rise again to the famous equation, balik-balikon ako, F is equal to ma. And take note, along x, baka na siya nga motion, ni-accelerate, along y, or along z. The other one is what we call as the law of interaction. For every action, there is always an equal but opposite reaction. So one of the basic example for this one is, yes, an apple resting on top of a table. So ang table mo exert og upward force on the apple in the form of normal force, for example, and then ang apple pod mo exert og force on the table or on the earth, on the apple, in the form of weight. And pwede pod, for example, mo-obey pod og Newton's third law, ang cannon being fired. So ang tendency, ang ball is towards this direction, while the cannon itself is on the opposite side. Even ang example, if you're going to mudagan ka, on a boat. So, diri nga direction, so ang boat pod mo exert og same amount of force, mo move siya with the same amount of force in the opposite direction. And even the rocket. So, basically, ang motion sa object or ang rocket is upward, pero ang gas would be the opposite way around. Ang gas nga gi-exhaust gikan sa engine is paingon diri ang side. So basically, two forces on different bodies pero of equal magnitude but then opposite ilahang mga directions. So take note also nga we will be dealing with free body diagrams in solving problems nga naa sa Newton's laws. So again, you need to resolve the forces into its components. For example, na object rest in equilibrium, so ang tendency, ang forces nga naa is basically normal force, which is upward, and your weight, which is simply downward. And if you have an accelerating object, given that this surface here kay rough, so ang tendency, ang forces nga naa is 1. This applied force F, the normal force, kay na platform, and then the weight, which is simply downward, and also the friction. Okay, so if you'll notice. And the next, what if naka-inclined ang usa ka object, so most likely, ang imo pong x and y axis will be rotated. So, ang tendency, imong normal force kay perpendicular sa incline. So, ang tendency, na imong normal force into this direction. Okay, and then ang weight, which is simply vertically downward. So, ang tendency that would, the free body diagram would look like this. Okay, so rotated imuhang x and y. So again, I repeat also there are strategies for this one. You need to visualize the situation first. And then also, one is that consider one body at a time. So kada object, kada mass, laylahi na siya og free body diagram. And also, you need to identify the forces gaak sa object. Okay, and then, again, I repeat, if several bodies are involved, draw a free body diagram for each body separately. And you must resolve the vectors into its components. You cannot just simply add F, the applied force, diretso sa weight. You need to use components for that one. And then take note, first law, net force is equal to 0. Each component has, so pasabot kay along x, along y, and along z. F is equal to ma kung second law, and then Newton's third law. There are actually 4 important forces that you must remember for this topic. One is the normal force. Kini ang force nga perpendicular to the surface of contact. So there are two cases unsa ang dagway sa imong normal force. One is on a level surface. So for this case, imong normal force is ang force exerted by the platform onto the object. Okay, so for this case, that would be upward, and then ang weight dayon, ang force exerted by the mass m onto the floor. So since the object is at rest for this case, so acceleration is simply equal to 0. So that would only mean that we're going to use Newton's first law. Summation of forces along y is equal to 0. So all you have to do is to add that forces na nasa y-axis and nasa y component. If it's towards positive y-axis, positive na siya nga force. Kung padulong siya sa negative y-axis, negative food na siya nga force. So normal force kay paingon sa positive y-axis, that is y positive, and then negative ni siya kay paingon sa negative y-axis. Equate this one to 0. So ang tendency, mag-add kag weight both sides of the equation. So for this case, imong normal force kay equal lang sa weight. Next, ay kaduha nga case kay naka-incline imuhang surface with an angle of inclination theta. So for this case, murag pa-tilt pud imong x and y axis. Okay, take note nga ang normal force kinadri nga direction and your weight is simply vertically downward yun na siya ang weight. Dili yun na siya always along with the negative y-axis. Okay, so again, acceleration is equal to 0 and shall we say that frictionless ang floor. So ang tendency is that you'll have summation of forces. Again, we're gonna use Newton's first law, summation of forces along y is equal to 0. So take note nga lang taon ni mong vector weight ang gravitational force wala galay along x and y. So ang tendency is that I forgot to mention kung pilang angle of inclination is equal also sa angle gikan sa negative y-axis paingon sa weight. So meaning to say this is also equal to theta. Okay. And to use component method for this case is that all we have to do is simply component method na to sila. So ang tendency is that nakoy wy. Okay, right? This is your wy. And this is your wx. Okay, take note that ang equation sa weight is simply equal to mg. Mass times acceleration due to gravity. Magnitude, ang direction kay tara. So, here is that wala ning mg component method na. So, your wy is on the adjacent side of angle theta. So, cosine. So, you'll have w cosine theta. And your weight is simply equal to mg. So, that means to say you'll have mg cosine theta. Same as true for your wx. Kung ganahan mo nga i-component method ang wx, it's on the opposite side of angle theta, so sine. So you'll have w sine theta. So you'll have mg sine theta. Okay. So here, next is that add the forces along y and then equate that one to 0. So ang duha ka forces ang nasa y, your normal force and the y component of the weight. So you'll have positive ang normal force minus ang weight. Anong negative? It's because downward. So you don't have to put negative here. Magnitude ra kung i-calculate diri. Ang direction niya nara diri. So and then equate that 1 to 0. Subtract wy both sides of the equation. So your normal force is simply equal to the y component of your weight. Next is the frictional force. There are two types of friction or frictional force. One is what we call a static friction. Take note, ang friction kay katutong force nga always opposes the motion of the object. So when we say static friction, iyang pugngan nga move ang imuhang object. So here, for this case, although there's an applied force, pero if you'll notice, the object is still at rest. So ang friction nga naa dira is what we call a static friction. Static meaning to say at rest. So once ma-overcome niya, mudako ang applied force kumpara sa static friction, unang in motion ang object. So if you'll notice on this figure, look at the ant. The moment it pushes the block, so at first, ang tawag ana niya is static friction na siya. For the moment mo move na ang block, lahi na nga friction ang present and that's what we call as kinetic friction. So ang frictional force acting on the object when the object is in motion. So ang tendency is that you'll have here the accelerate, ang friction nga present is not anymore static but what we call as kinetic friction. So ang equation is simply equal to the coefficient of kinetic friction times the normal force. Take note that this is the property of your kaning coefficient of static friction kay wala na siya unit. It's basically based on the property sa surface. Kung rough, meaning to say dako-dako og value sa imuhang mu k, pwede siya dili siya molapas og 1. And if it's smooth, so almost equal to 0 ang iyahang value. So same as true for your Fs or static friction, so you'll have mu s times normal force. So take note that dili sila the same ha. Di gyud sila magkuyog sa usa ka free body diagram, guys. So ang static o imong kinetic friction. You need to identify kung rough ba ang surface or kung frictionless, zero ang friction. Pero kung nag-move ang object and then high friction ang floor, so a tendency you'll have here, kung nag-move, that would be kinetic friction, kung at rest, static friction. So here, again, I repeat, what's the difference between the two? Though I applied force, will I motion, static friction. I applied force and in motion ng object, so kinetic friction. The third one is what we call as tension force or tension, denoted as T for this figure. So kanitong forces nga gi-apply, gi-transmit paingon sa cable, string, or wires. So ang tendency is that the tension is always directed along the length of the cord. So ang tension kay along yun sa kanang kung asa ang cord. Kung vertical, vertical po di mong tension. I mean rather horizontal, horizontal. Kung vertical, vertical po di mong tension. So here, they equal ilang magnitude but then opposite nga directions. And lastly, what's the difference between your mass and weight? Ang mass is the amount of inertia nga nasa imuhang object. When we say inertia, i-resist niya ang motion sa object. Inertia, i-resist niya kung atras siya, i-resist niya nga move siya, or kung nag-move siya, i-resist niya nga mo stop siya. Muna ipasabot sa inertia. So its SI unit is in kilograms. And take note, it's a scalar quantity wala siya direction. But when we say weight, it is simply ang pull of the Earth's gravity on any object na ay mass. So for example, ang equation niya is simply mg. And take note that g is the acceleration due to gravity. So ang magnitude kay 9.8 meters per second squared. So for example, here I have here a ceiling fan which has a mass of 1 kilogram. So ang tendency is that its weight is simply equal to 9.8 newtons. Okay, here on Earth. Pero if we'll move that ceiling fan, that una ko ning ceiling fan paingon sa moon, so iyahang weight is basically mag-change. Same ra gihapon ang iyahang mass. So you'll have here, shall we say, ang acceleration due to gravity sa moon kay 1 meter per second squared. So ang tendency is that iyahang weight is nag-change. Okay, nahimo siyang 1 Newton.